Pluto, which once used to be a part of our solar system, is still captivating our scientists and people in the form of a dwarf planet today. Since its discovery in 1930, Pluto has remained a mysterious world far away for us. Perhaps that's why the name Pluto was named after the god of the underworld, Hades. In 2015, the New Horizons mission's historic flyby gave us the first close-up view of Pluto, revealing a dynamic and complex world. Vast glaciers, towering mountains, and a hazy atmosphere, these discoveries have made Pluto even more mysterious. But as we learn more about Pluto, a very strange question arose. Could there be hidden life somewhere in this icy world? At first glance, it seems that Pluto is not suitable for life. The temperature here is extremely cold, almost minus 225 degrees Celsius. It is so far from the sun that it only receives a fraction of sunlight compared to Earth. But even then, a recent discovery has created excitement among scientists. They believe that there could be some essential ingredients for life hidden beneath the frozen surface of Pluto. In today's video, we will explore the possibilities of hidden life on Pluto. We will look at the conditions of this dwarf planet, the surprising findings of the New Horizons mission, discoveries and extreme environments. The potential for life. Can Pluto, with all its limitations, harbor any form of life? Let's go on a journey to the unknown realms of Pluto and discover the mysteries of this distant world. In the rain, to understand the potential for life on Pluto, we must first focus our attention on the conditions of this distant dwarf planet. Pluto is located in the Kuiper Belt, which is a region beyond Neptune, where icy bodies and early solar systems are found in abundance. Pluto is a frozen world, a world whose surface is primarily made of nitrogen ice. Traces of methane, carbon monoxide, and water ice can also be found on its surface. Pluto's surface temperature is one of the coldest temperatures in the solar system, which is typically around minus 225 degrees Celsius. Due to such extreme cold conditions, the entire surface here is covered with solid water, which makes it an unlikely environment for life. However, recent findings suggest that Pluto may not be as inhospitable as it first appears. The findings from National Aeronautics and Space Administration's New Horizons mission are the most exciting, even baffling scientists. New Horizons has discovered the presence of a subsurface ocean beneath Pluto's icy crust. Most of our knowledge about this hidden ocean comes from a single surface feature on Pluto, named Sputnik Planitia, which is shaped like a large heart. This area appears to be a giant sheet of nitrogen, ice, and methane in the form of a nitrogen glacier. The smooth and crater-free surface of this region suggests that there must have been recent geological activity on Pluto. Scientists believe that the presence of a subsurface ocean can explain the features seen on the surface of Pluto. For example, the cracks and ridges on Pluto's icy shell, which are likely due to the slow freezing of the ocean, could be an explanation. In addition, the New Horizons mission also provided hints of ammonia on Pluto's surface, which could suggest a liquid ocean beneath Pluto. This is because ammonia acts as an anti-freezing agent, which lowers the freezing point of water. This suggests that there could be pockets of liquid water on Pluto, even at such low temperatures. If there is any subsurface ocean on Pluto, it could potentially be a habitat for life, just like life thrives in extreme environments on Earth. We have seen deep-sea hydrothermal vents where organisms survive without sunlight and depend on chemical energy. It is possible that such conditions exist on Pluto, where life, chemical reactions, and geothermal energy could flourish beneath the ice in submerged oceans. Indeed, there was another surprising finding from the New Horizons mission. The ongoing geological activity on Pluto was initially thought to be due to the planet's flexibility, which was believed to make Pluto a cold and dead world where geological activity would be virtually non-existent. But when we observed the landscapes through this mission, it completely changed our entire expectations. Pluto's surface is filled with a variety of terrains including vast plains, high mountains, and deep valleys. Sputnik Planitia is a very large heart-shaped region which is a very large ice plain, mostly made of nitrogen ice. The surface of this lake is relatively very smooth because there are very few impact craters here, which suggests that the surface of the dwarf planet is constantly renewing. Perhaps all the surface ice in the convective cells is another geological activity, evidence of Pluto's mountains, such peaks that are primarily made of water ice. These mountains go up to about 2.17 miles. They are comparable to our Earth's Rocky Mountains. Such a big mountain. This indicates that Pluto's crust is strong and rigid, made of water ice, which can also support massive structures. The presence of water ice mountains and nitrogen ice plains on Pluto indicates a complex and active geology. But the question is, what could be the factor driving these activities in the end? A very strange possibility is that heat generated from radioactive decay could also exist, which might be present in Pluto's core. When radioactive elements break down, they release heat, which could potentially maintain a subsurface ocean and drive geological activities on Pluto's surface. Another very strange possibility is the existence of cryovolcanism or ice volcanoes. Traditional volcanoes that we see on our planet, they erupt molten rock, but cryovolcanoes erupt water, ammonia, or methane. New Horizons observed some very large dome-like structures on the surface of Pluto, which could be cryovolcanoes. If it is true that there are cryovolcanoes on Pluto in reality, all this could provide evidence for the surface ocean. This also suggests that liquid water mixed with other chemicals could also reach the surface of Pluto. The discovery of active geology on Pluto also gives life to the possibility that this dwarf planet could provide the necessary conditions for life. Geological activities also play a crucial role in supporting life ecologically, such as recycling nutrients and providing energy sources like hydrothermal vents. If such processes are happening on Pluto, it could create habitable environments beneath its icy surface. It's possible on Pluto's surface, raising an exciting question of astrobiology and ongoing geological activity. Could life exist in such extreme environments on Pluto? To understand this, we need to see what we know about extreme environments in the first place. There are such extreme places on our Earth as well, which seem inhospitable at first glance. Here, conditions seem very difficult for life, but we still find life here in some form or another. Take for example these deep sea hydrothermal vents, which are found throughout the entire ecosystem. But the life here that thrives relies on chemical energy coming from the interior of the Earth. And even deep underground rocks have been explored up to this point. Such organisms that can survive even in extreme conditions are called extremophiles. This shows that life can adapt to a very wide range of environments which seemed impossible to us before. If life on Earth can thrive in such extreme environments, it is conceivable that a similar form of life could exist on Pluto. If all the surface of Pluto is frozen, it can provide a stable environment for the development of life. Then again, even if the oceans are extremely cold or completely dark, life could still survive there. They will depend on chemical reactions for energy. In other words, they will be extremophiles. Along with ammonia and other complex molecules on Pluto, this suggests that its oceans could have the building blocks of life. Ammonia plays a crucial role in the formation of amino acids on our Earth, which are the building blocks of proteins. If similar chemical processes are happening on Pluto, it somewhat increases the possibility of life existing there. However, it's equally important to note that the conditions on Pluto could potentially support life, but so far we have not found any direct evidence of life there. Subsurface oceans and geological activities are just intriguing clues, not proof. Whether there is life in Pluto's hidden oceans or not, we need to explore and study more to understand this. Future missions and exploration have fundamentally changed our understanding of Pluto at a discovery level, and there are still questions about the potential for life in this underworld. Missions will need to be sent to Pluto in the future to answer these questions. A sample return mission for Pluto, like the exciting project proposed, would involve an orbiter and a lander. The orbiter will give scientists the opportunity to study Pluto in more detail, for mapping its surface, analyzing its atmosphere, and searching for signs of geological activity as well. Lander will provide us with direct measurements of its surface and subsurface, and perhaps help us detect any subsurface oceans or life-supporting features. Another mission concept for Pluto is to send a probe there. It will study the atmosphere and surface chemistry of Pluto. This mission will use advanced instruments to analyze the composition of Pluto's surface and atmosphere. It will search for organic molecules and certain compounds that could be indicators of life. Special missions targeting Pluto will also be launched to explore the Kuiper Belt in the future. They can search for signs of life in this region of the solar system far beyond their journey. There are also other bodies in the Kuiper Belt which are similar to Pluto. By studying these objects, scientists can understand the processes that shape their surfaces and interiors, and what could be the scope of their habitability. National Aeronautics and Space Administration's New Horizons mission also flew by another Kuiper Belt object in 2019 known as Arrokoth, formerly known as 2014 MU-69. Its unique shape and surface features have given scientists a glimpse into the early history of the solar system. Here, New Horizons has collected a lot of valuable data. Future missions, like the Kuiper Belt and its potential life, will search for more. They can. However, no mission is currently scheduled for Pluto or the Kuiper Belt. However, after New Horizons, interest in these distant worlds among scientists is growing. Advanced technology and space exploration make it very likely that we will return to Pluto in the coming decades. New Horizons has dug up some deep secrets here. We will have to return to Pluto to find the answers to those mysteries. Our journey will continue to inspire and challenge us. Conclusion: the mystery of Pluto is a world filled with surprises, which we once thought was cold and dead, is now showing us in a dynamic and active form. Our own searches have forced us to think that there could be some very necessary ingredients for life near Pluto, although we have not found any direct evidence of life on Pluto till today. But it certainly challenges our understanding and will also be beneficial for our future. With new missions and technologies, we will have the opportunity to learn more about this distant world. And then maybe we will find potential clues to life here as well. Please subscribe to our channel and hit the bell notification for informative videos. Make sure to enable notifications. Stay tuned for space exploration, science discovery, and deep dives. See you soon, friends.